Welcome back to this video lecture series on data structure and algorithms. Today our lesson is stack implementation as array. So in the previous video we had known about the theoretical part of the stack, like what stack is, what operations we can do on stack. Today we'll be looking how to implement stack using the data structure called array. So let's start with this structure of stack. When we are implementing stack as an array, the structure of the stack, when we will write it in code form, then the structure will have three things in it. One will be the top, which will have a type of integer. Then we have to mention the capacity of the stack, and lastly we will take a pointer to an array which will contain integer types of data. So in this diagram here we can see the stack is 1752, where the top element of the stack is 1. So now if we implement it as array, then the last element added into the array will be the top of the stack. So as you can see that there are 4 indexes, 0, 1, 2, 3, and the last index, that is 3, this index contains the top of the stack. So top is the single end of the stack from where all the operations will take place in stack. Capacity actually is needed to check for the overflow and underflow state of the stack. And lastly, the array will be used to contain the data items. Now we will see some of the operations that we will be doing on this stack. So the first function is push. This function adds a data element into the stack and increments the top of the stack. Then comes the pop. It removes the data element at the top of the stack. Now when we are concerned about this two particular states called underflow and overflow, we have to inculcate two functions here. One is empty, which will be checking for the underflow condition, and the next is full function, which will be checking the overflow condition. One thing that we should remember, that whenever we create a stack, then always the value of the top will be -1. When we will be checking the underflow condition, we'll mainly be concentrating on the value of the top. If we find that the top value is -1, then we can comfortably say that the stack is empty. Now before jumping onto the coding part, let us just have a look, or let us just get ourselves know with the advantages of this stack as an array. Well, as an advantage, we can say that the stack, when implemented as array, it consumes less memory because there's no extra overhead for containing the pointer. But there's a disadvantage too, that is we can't use the dynamic feature of programming here. So we have to mention the size, and we also have to deal with the thing that during runtime we cannot really shrink or grow the array. So let's jump onto the coding part and let's see how we can implement stack as an array. So I have opened my IDE and I will start coding right from here. So hashtag include stdio.h. we will add two more libraries here. One will be standard library.h, another will be limits.h. So now let's start with the main function. So this will return a value 0. Now we will first have to mention the structure of the array. So let's take struct stack, and the structure will be, one will be top, which will be integer, then we'll be having this unsigned type of capacity, and lastly we will be having a pointer to an array. So now in this main function we will be creating this stack, but just the variable only. So let us name the variable as s, and here we will actually invoke a method or function actually. So create stack, and here we will give an input which will be the capacity. So for this program, let us say we will input 100 capacity. So now it's time to define this function. So this create stack function, we can see that it returns struct stack star, and this will be unsigned capacity. So first we'll have to allocate memory for a data element. So struct stack star s is equal to, again, the type, we'll use malloc here, and this will be size of struct stack. So the memory allocation part is done. Now as we are creating the stack for the first time, so the top of the stack will be assigned a value of -1. The capacity will be is equal to capacity, and lastly for the array we'll again use malloc here. So malloc, and here this will be capacity into size of integer, because we are storing integers in this array. So with this we are done with this create stack function. Just we have to return the stack. Okay, so now what we will do, we will perform push operations. So this function will take the stack and the data we want to enter. So let's say we will be entering various data, so let us just do it manually, that is from the program itself. We'll be pushing 5 elements, say 2, 3, 4 and 5. The values will be different, like this will be 4, this will be 7, this will be 12 and this will be 9. Then after we will pop it. So I will just first create the whole structure of the main function, and then I will go on and define these functions. Now I will pop the top of the stack, so I'll use this pop function which will have the stack pointer as its argument, and I will also print this message that the popped value is %d and this is I. And lastly we will print the stack here. So while s top is not is equals to -1, what we'll do is we will print the values and s array s top, and we will simply increment the top value, or sorry, we will actually decrement the top value. So this should be the main function. Now let us first define the push function. So it will have a void return type, and the arguments to this function will be firstly struct stack star s and then an integer value, let us say data. So here we have to just push the value into the stack. So for that we'll first check the is full condition, that if the stack is in overflow state then we will not be able to push, right? So we will again use a function is full s. If this is the case then we will simply return, that's it. Otherwise what we'll do is we will actually enter this data, this will be s array. What we'll do, we'll simply pre-increment the top and we'll assign the value here. So why we pre-incremented it? Because we have to first increment the value of the top so that a new index is created in the array and then store the value. So before going forward with the pop function, let us first define this is full function. So again, this is a function with return type of void, and the type of this argument will be struct stack. Now this will also check some conditions. Now if s top happens to be s capacity minus 1, then it will return 1, that is, yes, the stack is full actually. Otherwise it will simply return 0. Now after push, we will actually define the pop function, which will return an integer value. So pop, and inside the argument will be struct stack star s. Here again, first is empty condition will be checked for the underflow state. So let us just first declare this function is empty. We'll pass the stack pointer here and we'll simply return. So yes, otherwise what we'll do is we will return the stack array and we will return this post decremented value of the top, and then accessing that index. So again we have to define this is empty function. The argument will be struct stack star s. Again here we'll first check the condition. If s top happens to be minus 1 only, then obviously it is an empty stack, so we will return 1. Else what we'll do is we will return 0. So we have defined all the functions. Let us just check create stack, push, pop, and so pop is there, is empty, push is full, create stack. So yes, we have done all the definitions of this functions we have invoked here, and we have written the code. So let's just now run it and see whether it's been done correctly or not. Okay, so the output is here, and the data push sequence is being printed properly. First we pushed 2, 4, 7, 12, 9. So after all the push operations, the top of the stack should be 9. So when we pop, the pop value is shown as 9, and then after the 9 is popped from the stack, 12 should be top of the stack, and the traversal should start from here, and yes, it's been printed properly. So this is how you can implement the stack as an array. Thank you for watching this video and staying with us. See you next time.